All right, assalamu alaikum everyone. Welcome to lesson number 4. Today we will be basically doing some advanced nomenclature for haloalkane. So you can consider this to be the part B of the nomenclature of haloalkane. So some of the rules that we have already seen are as follows. We have already seen that we always count the longest consecutive carbon chain to decide the prefix, and then we look at the functional group to decide the suffix. And we basically saw in whichever molecule we have a CX bond, we name that as a haloalkane, and the suffix remains "ane." The different part only is that the name is preceded by this bromo, chloro, fluoro, iodo, depending on the halogen we are talking about. And we have also seen the fact that the carbon with which this halogen is attached, we give it the highest priority. Highest priority basically means we give it the lowest possible number. We basically number the chain in a way that this carbon gets the lowest possible number. Now, in order to basically deal with haloalkanes which have more than one CX bond, so for example, you have a CCl bond and then you have a CBr bond. Now, in such halogens, when you have like two halogens attached in a molecule or even more, in that case, we need to deal or know at least these two rules as well. So, the rule number 4 says that whenever multiple halogens are involved in a molecule, we give a Greek numerical prefix like di, tri, tetra. How do we use these names? I'll get to that in a minute. And number 5 is that the naming is done alphabetically. So, for example, if in a molecule you have Br and Cl attached, whichever name comes alphabetically before the other one, we will name it or write it before. So, for example, bromine starts with B and chlorine starts with C. So, which one comes before in the alphabetical order? Definitely bromine, right? Because B comes before C. So, we will name it before we name chlorine. All right. So, this is basically what you need to keep in mind. And let's see how we will do this. Now let's do some questions and perhaps it will get more clear. All right, so in the first example you can see it's still a monohaloalkane. Mono because there's only one halogen which is in this molecule. So like before, let's count the longest carbon chain. So this is 1 2 3 4 5 and 6 carbons. So because I see 6 carbons, I can call this as a hex. Now, because I can clearly see that we have a halogen attached, we will end it off with ane. So this is hexane, but that is just the alkane part of it. We need to also mention the you can say we also need to mention the halogen part. So in the halogen part, we can see we have a chlorine attached, but before we do that, we need to number this chain. I'll start numbering from this side. So I'll say 1 2 3 4 5 6. And why did I start numbering from this side? Because I wanted the carbon with which the Cl is attached to get the lowest possible number. Had I started from this side, it would have gotten number 5, which is not something that we want. We want to give the lowest possible number, and that is why this now, my friends, is 2-chloro hexane. However, also keep note of the fact that we have a CH3 attached over here as well. So there's a methyl group and we need to deal with that as well. Now, usually we give preference to our halogen bit more than we give preference to our alkyl groups. So because the halogen part is given more precedence, we will put it first, and then in the middle I will add 5 methyl, and this will be the name 2-chloro 5-methyl hexane. Keep note of the fact that we separate our alphabets and numbers with dashes. This is something which is extremely important. And usually, as I said, we give our haloalkanes, or basically we give our CX bond greater preference than a alkyl group. All right, and that will be the case with any other basically functional group as well. So in one of the coming videos we will look at our hydroxyl group, and even in that case this will be given more preference over alkyl. Now definitely we can start comparing this with this as well, but we won't do that just yet. Instead we will just focus on haloalkanes, and the only thing we will insert for now other than the haloalkane molecule, other than the halogen, is an alkyl group. So just for now, remember that the CX bond is given higher precedence than the alkyl group, and the this is the reason why we number this chain such that our carbon with which Cl is attached gets the lowest possible number and not the carbon which has an alkyl group attached. So this is given the mode preference, and this is why this is written first and the 5-methyl is written later. It is written later on. All right, so I hope that makes sense. Let's go and talk about the second molecule. So in the second molecule, we have 1, 2, 3, and 4 carbons. So this makes it butane, right? But, because there are 4 carbons and we know it's a haloalkane, so it will end with ane. Now, apart from that, let's number this quickly. 1, 2, 3, 4. And in this case, basically, we have 2 bromines. So one bromine here and another bromine over here. Now, make sure that you understand that even if we started from this side, it would have made no difference because the bromines in this case are at 2 and 3 position, and even in this case they would have been at 2 and 3 position. So it doesn't matter how you number it in this case. So for now, I'm numbering it like this. Now comes the part where we talk about the rule number 4, which says that multiple halogens are given Greek numerical prefixes di, tri, tetra. Now, over here, what you see is 2 bromines, right? So how do we actually mention this in our naming? We say, or we call this, instead of just saying bromo, we say dibromo. Why do we say dibromo? Well, di stands for 2, tri stands for 3, tetra stands for 4, and usually you won't be asked to name anything which has more than this, so it is going to be di, tri, and tetra. So in this case, you can see you have 2 bromines. So what we do is we call this as dibromo. So the person who is reading this name would understand with because of this di that there are 2 bromines attached in this molecule. Now we need to specify the position of each of these bromines. So we need to tell the reader these 2 bromines are attached exactly on which carbons, and so we do that by saying 2, 3 dash. Now, important thing to note over here is that we separate our numbers with commas and we separate our numbers and alphabets with dashes. And so the name of this molecule is 2, 3 dibromobutane. So it tells the user, well, you have 4 carbons, you have 2 bromines, and these bromines are attached on the second and third carbon. So I hope this naming has made sense to you. Let's move on. So let's now talk about this molecule right over here. Now, in this case, we have 1, 2, 3, 4, 5, 6 carbons, and so this is going to become hex again. So I'm going to write it here, hex, and it's going to end with ane. Remember, it's a haloalkane, that's why. And what I see is I see a bromine molecule attached and a Cl molecule attached. Now, in this case, when you have a bromine attached and you have a chlorine attached, we give more preference to bromine. However, this is not like, it's not a compulsion, right? But we usually in the numbering, we would give bromine a higher preference. Though this is not a rule as such, what we're actually looking at is a way to give both bromine and chlorine the lowest possible number. So if I start from here, I have 1, 2, 3, 4, 5, 6. So in this case, Br is on the 3rd carbon and Cl is on the 5th carbon. If I decide to do it in another way, it will be 1, 2, 3, 4, 5, 6. In this case, I have Cl on the 2nd carbon and bromine on the 4th carbon. Now, this is definitely better than this, right? Look at this one. In this case, we have 3 and 5. In the other case, in this case, let me label it. In this case, we have 3rd carbon and 5th carbon. However, in this case, we have 2nd carbon and 4th carbon. Definitely, we will favor this numbering over this numbering because this gives the lowest possible numbers to overall it gives the lowest possible number to both of our carbons, right? And so that's why we will prefer this numbering over bromine. But in the naming, we will definitely give bromine preference and write it first. So this will become 1, 2, 3, 4, 5, 6. Now, because bromine starts with the B, that comes before in alphabetical order, then chlorine, which starts from a C. So I will first write 4 bromo, 2 chloro, and this will be our name. 4 bromo, 2 chloro, hexane. Now let me quickly recap what we have just said. There are 6 carbons, so we say hexane. there's a bromine, there's a chlorine. Which one do we actually name first? It is going to be bromine because it comes first in the alphabetical order. So bromo comes first, chloro comes second, and then we need to give them the numbers. And the way that we have numbered this chain is as such that overall we get low numbers for both of these. And so it is 4 bromo, 2 chloro, and that's your basically name. 4 bromo, 2 chloro, hexane. Now let's do our last example, which is basically right over here. So in this case we have 1 2 3 4 5 6 7 carbons, and so that is hept. Okay, so I'm gonna write it just about here because we need more space for this naming. This is heptane because we can see it's a haloalkane. And now let's number this. Definitely we'll start numbering from this side. Why? Because this will give the lowest possible number to both of our carbons. If you start from this side, it will be 1 2 3 4 5 6 7. So that's definitely not that's not giving the lowest possible numbers to our carbons with halogens attached. So we will definitely give this one and this 3. So in this case, you can see you have 2 halogens and you have an alkyl group. Remember this rule that our haloalkane or CX bonds are given more preference over alkyls. So in the naming, we will follow this, all right? And we're gonna write this down as, so first of all we write bromine because that comes, let's first like do a comparison between bromine and chlorine. So forget about the CH3, just imagine that it doesn't exist for now, all right? Now in this case I'll write bromine first, so this is 1 bromo, and then I write chlorine and this is 3 chloro. Now that I'm done writing my haloalkanes, I've dealt with the order in the naming order of my haloalkanes. Now let's concern ourselves with this methyl group. Now this methyl group is on the 4th carbon, and so the way that we will now name this is we'll write down 4 methyl, and there you go. So 1 bromo, 3 chloro, 4 methyl heptane is your answer. Now recapping this quickly, there were 7 carbons, so we wrote it as heptane, and then we had a bromine, 2 halogens attached, so we first sorted out the preference between them. We gave bromine more preference over chlorine because of the alphabetical order. So it was on the 1st carbon, we wrote 1 bromo, and then chloro was on the 3rd carbon, so we wrote 3 chloro, and then after that on the 4th carbon a methyl group was attached, and so we later concerned ourselves with alkyl because CX is given more preference over alkyl. So once we're done with the CX, now we concern ourselves with the alkyl. It's a methyl, it's on 4th carbon, and so we write 4 methyl heptane. So I hope that all 4 of these examples are clear to you. We will be doing these question solving videos separately. The concept or the point of these blue titled or these videos with a blue background are basically just to cover these theoretical concepts. Definitely the ones with red covers or red thumbnails will be those in which we will particularly be doing past paper questions. They will be coming up very soon, so stick around. And I hope that you enjoyed today's video. If you did, then give it a big thumbs up, subscribe to the channel, and hit the bell icon. In case of any queries, you can basically DM us on Instagram. The link is given in the description box below. Other than that, take care and Khuda Hafiz.